Hello, my name is Kevin Large and I'll be your instructor for today's session. In this session we're going to put IPv4 addresses under the microscope. So the first thing we're going to do is go and find an IPv4 address, and to do that we'll have a look at a Windows 7 host. How would we find the IPv4 information on this Windows 7 host? There are many ways, but one of the easiest ways is to use the command prompt, and we can access the command prompt by typing the Windows key and R at the same time on the keyboard. Pressing the Windows key and R at the same time on the keyboard brings up the Run dialog box. In there we can type CMD and that will bring up the command prompt. Now my command prompt looks slightly different than yours probably because I've got a white background with black text, whereas you've probably got a black background with white text. All I've done is I've gone into properties and changed the screen colour and the background colour. I just think it shows up a little bit easier this way. We can type ipconfig. We can see our IP configuration information. We can see the IPv4 address 192.168.50.62. That's the address we're interested in. We can also see the subnet mask and the default gateway. We can even see an IPv6 address. This is an automatically configured, automatically generated link local IPv6 address. It's actually represented in what's known as hexadecimal, so we have letters in there as well as numbers. But what we're interested in the moment is the IPv4 address. In fact, if I type CLS, this will clear the screen, and I type ipconfig /all, this will give us a lot more information. However, we're not really interested in the Windows IP configuration information at the moment, things like the host name, and definitely not the tunnel adapter. We're interested in the Ethernet adapter. This is our actual network card, our local area connection. We can see it's an Intel card. We can see its MAC address, which is its hardware address. It's a 48-bit address in hexadecimal. We can see the IPv6 link local address again, and underneath 192.168.50.62, which is our IPv4 address. This is the address we're interested in. So what can we say about that particular address? Well, first things first, let's zoom in on that address. Okay, so all I've done, I've blown the screen up slightly and we've highlighted the address that we're interested in, 192.168.50.62 in red. What can we say about that particular IP address? Okay, let's bring a whiteboard up. 192.168.50.62. Well, the first thing's obvious, of course. It is an IPv4 address. So that's an easy one. What else can we say? Well, the first octet, the first block of 8 bits in binary, or in this case 192 in decimal, 192 means it's what's known as a Class C address. Okay, that's good. What do I mean by these address classes though? Well, let's have a little think about that one. We'll go back to the presentation. We'll have a little look at the IPv4 classes. Okay, so this is how a human would see an IPv4 address, 192.168.50.62. This is not how a computer sees it. The humans see it in the form of dotted decimal. So the decimal numbers, they're separated by dots. Each decimal number is a conversion from an 8-bit binary number. So let's have a little look at those binary numbers. What I've done is I've converted 192 into its binary equivalent. The first bit is worth 1, the second is worth 2, the third is worth 4, the fourth is worth 8, the fifth is worth 16, the sixth is worth 32, and the ones we're interested in are 64 and 128. So the bits literally double every time. 64 and 128 gives us 192. And likewise 168 converts into 10101000, and 50, we can see what that converts to, and 62 again. This address is precisely the same address as this address. However, one is in dotted decimal for humans, and the other one is in, well, dotted binary, which doesn't really exist, for computers. What the computers see is they see this. We just remove the dots. So there is a 32-bit IPv4 address represented in its binary form. Because there are 32 bits, a bit standing for binary digit, and because it's binary, so the base is 2, it's 2 raised to the power of the number of bits, or 2 raised to the power of 32, which gives us 4 billion addresses. Seems like a lot, but we've run out of them already because there's well over 7 billion people on the planet. Okay, moving into IPv4 address classes. There are 5 classes of IP address, and these were used a long time ago. They were used between 1981 up until about 1993, where classless addressing took over, and CIDR, classless inter-domain routing. The main classes were the class A, B and C, and these were widely used for what's called unicast communication. This is a single sender to a single receiver, single machine to a single machine, one-to-one. The most common form of transmission. We've also got the class D address, which was used for multicast communication, a single machine to a group of machines, one to many. This is widely used in things like streaming audio, streaming video, that type of thing. We have the class E addresses, which were reserved for future or experimental use. There are 128 class A networks. Each one can theoretically, and I really seriously mean theoretically, hold over 16 million addresses. There's no way you would approach even the tiniest fraction of that many addresses on a single network, because the broadcasts alone would make it completely unusable. Class B networks, there's 16,384 of those, each that can hold 65,536 addresses. Not all those addresses are usable though. We'll get onto that later. And then the Class C networks, there's over 2 million of those. Each one can hold 256 addresses. Again, not all usable though. Okay, looking at a Class A address, well, the very first Class A address, right at the bottom, is 0000. That is technically a Class A address. And the last Class A address is 127.255.255.255. What makes them a Class A address is the fact that in binary, when we do the conversion from dotted decimal into binary, we can see that the very first bit is set to 0. If the first bit is set to 0, it's always a Class A address. We've got the lowest Class A address at the top, the biggest Class A address at the bottom. And when we're dealing with a Class A network, or Class A address, we know that the first octet is the network. So if the first octet is, say for instance, 8, and 8 is obviously between 0 and 127, so it is a Class A address, not only will that first octet's most significant bit, the leftmost bit, be a 0, but also it will be the 8 network, and the remaining 3 octets will be the hosts. So we have the network octet, and then we have 3 host octets. You can see now why there are so many hosts that you can have on a Class A network. And the Class A network will have a default subnet mask. It's very easy to calculate the default subnet mask. All we do is we convert all of the network bits, in other words the first octet, into ones, which gives us 255 in decimal. And we leave the host bits set to zeros, which gives us 3 zeros. So the default subnet mask for a Class A address is 255.0.0.0. There's a typical Class A address, 10.1.1.4. Because 10 falls between 0 and 127, it's a Class A address. You can see it starts with a 0 in binary. Again, it's a Class A address. So we've got network host host host. So the default subnet mask would be 255.0.0.0.0. Excellent. That subnet mask, by the way, can be represented as a /8 because there are 8 bits set to 1 in the subnet mask. Okay. Why are there 128 Class A addresses? This is why. Because the first bit in the address has to be set to 0 for it to be a Class A address. We can't use the first bit because that's the address identifying bit. It's a Class A address, it's set to 0. But the remaining bits in the network octet, and there are 7 of those highlighted in green, 2 to the power of 7 gives us 128. That's why there's 128 Class A networks. The host bits, and there's 24 of those, are highlighted in blue. 2 to the power of 24 gives us that 16,777,216 possible addresses per network, which is madness, of course. In reality, we have to remove 2 of those addresses. That's actually what's known as the network address and the broadcast address. Get onto that later. So we only have 16,777,214 only. So there's their Class A addresses. The network address. The network address is where all of the host bits, so that's the 2nd, 3rd and 4th octet, the ones in blue, are set to 0 in the IP address. That's the definition of a network address. Convert to binary, set all the host bits to 0. That's your network address. So for that 10 network, it's 10.0.0.0. The broadcast address is quite the opposite. That's where all the host bits are set to 1. And that again is a definition. You want to know what the broadcast address is? Convert to binary, set all the host bits to 1. There's your broadcast address. Anything in between is a valid host. Moving on, the Class B address starts at 128, where the Class A is finished. And it goes from 128.0.0.0 to 191.255.255.255. We'll speed up a little bit now. You can see the pattern. It starts with a 1 and a 0. If it starts with a 1 and a 0, it will be a Class B address. And that's why we have the numbers 128 to 191. If it's a Class B address, we have the first 2 octets set to network. So it's network, network, followed by host, host. The last 2 octets being the host octets. In this particular case, we've got 128.0.0.0 and 191.255.255.255 being the lowest possible Class B address and the highest possible Class B address. It's pretty easy to work out now that the default subnet mask for a Class B address, because the first 2 octets are set to network, we just make the first 2 octets all 1s in binary, which gives us 255.255.0.0, and that is your default subnet mask. If you apply a default subnet mask to the default class of address, it's known as classful addressing. So any Class B address with 255.255.0.0 is classful addressing. Okay, here's a typical Class B address, 172.16.10.10. What we will do now is we will look for the network address. First of all, of course, that subnet mask can be represented as /16 because there are 16 1s in the subnet mask. Right there. There's 8 of them. And there's the other 8. So /16. With this Class B address, because the first 2 bits identify that it is a Class B, they have to be set to 1 and 0. We have 6 bits in the first octet and all 8 bits in the second octet, so 14 bits in total for networks. This gives us 2 to the power of 14, or 16,384 networks. And we have 16 bits left over in the 2 host octets. So 2 to the power of 16 gives us 65,536 total addresses. Of course, as you know, we'll have to remove 2 from there because we'll have to remove the network address and the broadcast address. And now we'll look at the network address. Again, it's ever so easy to do. Convert to binary, set all the host bits to 0, and there's your network address. So 172.16.0.0. The broadcast address, convert all the host bits to 1, 172.16.255.255. Excellent. Classful IP addressing, Class C. 192.0.0.0 being the lowest, 223.255.255.255 being the highest. What do you reckon that will look like in binary? Well, first we had 0, then we had 1 0, so now we should have 1 1 0. That's precisely what we've got. So providing it starts with 1 1 0, that's the pattern we're looking for, you're looking at a Class C address. And that's why we have the numbers between 192 and 223. In this case, with a Class C address, we have network, network, network. The first 3 octets are reserved for the network. That's why there are so many Class C networks. And only the last octet is reserved for the host. That's why there's so few hosts on each Class C network. We can see the default subnet mask for a Class C is 255.255.255.0. Most people are familiar with that one. It's probably the most common subnet mask that most people see, because most people use Class C addresses. All we've done is we've looked at the network octets, which are the first three, and set the bits to 1 in the first 3 octets, which generates the subnet mask 255.255.0. Sorry, 255.255.255.0. Okay, typical Class C address. The subnet mask can also be represented as a /24 because there are 24 bits in the subnet mask. Now if you put a /24 on a Class C address like 192, it's class full addressing. In fact, if you put it on any number between 192 and 223, because they're Class Cs and you've put a /24 on it, it's class full addressing. It's only classless addressing when you put some other subnet mask other than the default subnet mask onto it. Okay, so what have we got? We've got 2 to the 21 possible networks. That's a lot of networks, over 2 million of them. We've got 2 to the 8 possible bits in the host portion. That's 256 possible combinations, 2 to the 8. So there's 256 addresses in the host portion. Minus the network address and the broadcast address. There is your network address, set all the host bits to 0. There is your broadcast address, set all the host bits to 1. It's pretty easy. Classful IP addressing the Class D address. The Class D address is a little bit odd. It's not used for unicast or one-to-one transmission. It's one-to-many, streaming audio, streaming video. You can see the pattern, 1110. So it's 224 up to 239. Something slightly odd going on now. They're all host bits, there's no network bits. This is because this address is put on top of a computer to tell it the computer that it's part of a multicast group. And that multicast streaming traffic is directed to that group. Anybody with that particular multicast address will receive that traffic. So this address goes on top of the computer's network card's already existing address. It's actually an additional address that's put onto the system. Okay, reserved for multicast. The Class Cs are experimental addresses. You don't see very many of them. You can see the pattern. It just follows on from where the last one's left off. Okay, so we've got default subnet masks. For the Class A, the default subnet mask is 255.0.0.0 or /8. The B, /16, and the C, /24. If you put a 24 subnet mask on any Class C address, it's classful addressing. If you put a 16 on any Class B address, it's classful addressing. If you put an 8 on any Class A address, it's classful addressing. However, if you have a Class C address and you put a 27 on it, or 28, or even a 16, anything but a 24, it's classless addressing. So it's only when you put the default subnet mask on that particular class of IP address is it classful addressing. Interesting. Okay. What else can we say then? We know it's a Class C address because it starts 192. What else can we say? Not an awful lot until we see the subnet mask, but there is one other thing we can say. We can say this. Let's just switch back to the whiteboard. Because the address starts 192.168 is actually known as what's called a private address. It's a private Class C address, in fact. Okay. An interesting thing with these private addresses is this. I'll show you. There are 3 classes of private addresses. There's A, B, and C. Obviously for the Class A addresses, the Class B addresses, and the Class C addresses. The Class A addresses are anything that starts with a 10. So 10.0.0.0/8. So anything that starts with a 10, the other numbers can be any numbers you like. Obviously they can't go higher than 255. That is a Class A address. The Class B addresses 172.16.0.0/12. That's an odd one. We'll break that one down. That means it runs from 172.16.0.0 all the way up to 172.31.255.255. That is an odd one. Yep. What's not an odd one is the class C's. 192.168.0.0/16. Because it's /16, it means the first two octets count. So anything that starts with 192.168 is a private class C address. And a private address cannot be routed on the internet. So the internet backbone routers, when they see a private address, they will just drop that address. This means that companies can actually use those private addresses without the chances of them overlapping on the internet. So a school, the supermarket next door, the car factory across the road, they can all use exactly the same address range privately inside their building, and they'll never overlap because those addresses are not allowed to be routed on the internet. As those addresses connect through the company's router to the internet, they're actually translated into a public IP address that's given to the company or the school or the college or whatever by their service provider. It's exactly the same at home. Your home address is probably a 192.168.0.0 address, or well, it's a 192.168 address. It may not be 0.0, of course. It may be 1.0 network or 2.0 network. However, it will start 192.168, so it's a private class C address, and your home router will actually use something called NAT, or Network Address Translation, and it will translate the private address. They're actually known as RFC 1918 addresses. That's what these addresses are known as. It will translate those private addresses into a public address that's been given to you by your internet service provider, which is routable on the internet. Okay, it's very clever. It actually allows you to translate many internal private addresses to a single public address. This is normally done with a technology known as PAT, or Port Address Translation. We're going a bit deep there, so we'll skip going any further than that for a moment into NAT and PAT. But what we do know now is we know that not only is that a class C address, but it's a private class C address. Okay, what else can we say about it? Well, pretty much nothing now without the use of the subnet mask. So what I'm going to do, I'm going to call that particular video an end, and we'll come back in part 2 where we'll see what else we can find out about that particular IP address with its subnet mask. What we will do just before we go is we'll have a little look at the Windows machine again, and we'll see what that subnet mask was. Okay, the subnet mask is 255.255.255.0. Now that's interesting. 255.255.255.0. That means something to me. Let's have a little look. Let's zoom in on that again. 255.255.255.0. Let's highlight that in red. That is the default subnet mask for a class C address, and we are actually using a class C address. So there is actually one more thing we can say, and that is this is a classful address. I'm not sure whether classful has 2 L's or 1 L, but anyway, this is a classful address because it's a class C address, and it's using the class C's default subnet mask of /24. So we've got a /24 on a class C, which makes it a classful address. So there was one last thing we could say about it. However, to say any more, we really need to bring the subnet mask into the equation. So what we're going to do, we'll have a little look at the subnet mask. And what was the subnet mask? 255.255.255.0, and we'll do that in the next video. Thanks very much for watching, and I'll see you in the next video where we'll try to work out 4 or 5 more things that we can do regarding that IP address and that subnet mask. Thanks for watching.